This is Rimrock Draw rock shelter, and what they found here completely demolishes the idea that Clovis culture represented the first Americans. Because these remains are more than 5,000 years older than Clovis. They're currently the oldest securely dated evidence of human occupation on the North American continent, and they raise a question that's been haunting archaeology for decades. If people were butchering camels in Oregon 18,000 years ago, how did they get here? For most of the 20th century, the answer seemed clear. The Clovis culture, named after distinctive fluted stone spear points first found near Clovis, New Mexico, represented the first inhabitants of the Americas. The model said people entered North America from Siberia around 13,000 years ago via a land bridge called Beringia. Then they moved south through an ice-free corridor that opened between massive ice sheets covering much of the continent. Clean, linear. First people arrive, spread rapidly, become Clovis. But later research tore that model apart. Studies showed the supposed corridor likely didn't become a viable, habitable passage until around 11 to 12,000 years ago. And even then, it may have been ecologically barren for centuries. No game, no plants, just ice and meltwater. An implausible route for people trying to migrate with families and survive. At the same time, pre-Clovis sites started accumulating. Meadowcroft Rock Shelter in Pennsylvania produced artifacts dated to at least 16,000 years ago. Cooper's Ferry in Idaho yielded early material of similar age. These sites indicated people were present in North America before the inland corridor opened, which meant they had to have used a different route. The leading alternative is the kelp highway hypothesis. People traveling along the Pacific coastline, exploiting kelp forests, marine mammals and shellfish, moving south in boats or on foot along now, submerged shorelines when sea levels were hundreds of feet lower. Rimrock Draw is about to make that hypothesis a lot stronger. The University of Oregon's Museum of Natural and Cultural History began formal excavations at Rimrock Draw in 2011, following earlier surface finds that suggested the site might hold ancient artifacts. The team used careful, modern methods designed to preserve fragile materials and maintain clean stratigraphic control as they progressively opened and deepened units inside the shelter. The first major breakthrough came when they started finding large animal remains in deep layers: teeth, jaw fragments, big bones. The identification came back as Camelops hestinus, yesterday's camel, a Pleistocene species that evolved in North America before the camel lineage spread to Asia and Africa and then went extinct in its homeland at the end of the Ice Age. These were massive animals, 7 feet tall at the shoulder, around 1,800 pounds. And the remains from Rimrock Draw weren't random bones washed in by flooding or dropped by scavengers. They showed deliberate human modifications, butchery marks, cut marks from stone tools. And they were found in direct association with stone artifacts right there in the same layer. Someone had killed this camel, processed it for meat and hides, and used the shelter as a butchering area or base camp. But the real revelation came from where the bones were found. They were lying beneath a distinct layer of volcanic ash. In archaeological stratigraphy, volcanic ash layers are like timestamps. They can be tied to specific eruptions through their geochemical signature. Each volcano has a unique chemical fingerprint. Match the ash to the eruption and you get a precise date. The ash at Rimrock Draw was chemically matched to an eruption of Mount St. Helens called the Set eruption, a major event that occurred more than 15,600 years before present, which meant anything sealed beneath that ash layer had to be older than that eruption. The camel bones, the butchery marks, the stone tools, all of it sitting below the ash. All of it older than 15,600 years. But how much older? To refine the age, the team performed radiocarbon dating on the enamel of one of the camel teeth. Tooth enamel is durable. It can preserve carbon from the animal's lifetime for tens of thousands of years if conditions are right. The result came back at approximately 18,250 years before present. That date means the camel was alive, and its tissues were forming 18,000 years ago. The butchery event, the human processing of the animal, happened around that time or slightly later, but still before the volcanic ash was deposited 15,600 years ago. 18,250 years. That's the last glacial maximum, the absolute height of the last ice age. And people were here, killing camels, processing meat, making tools, surviving. The stone tools found with the camel remains are significant in their own right. finely crafted scrapers made from orange agate. Agate is a high-quality siliceous stone, similar to obsidian or glass, that produces very sharp, durable edges when knapped properly. But here's the key detail. Orange agate doesn't occur naturally in the immediate basalt surroundings of Rimrock Draw. It's an exotic material. Someone had to bring it in from elsewhere. That implies mobility, knowledge of distant resource areas. Either these people travelled to specific locations to procure this stone, or they obtained it through exchange with other groups. Either way, it indicates logistical planning and possibly social networks spanning considerable distances. One of the orange agate scrapers recovered near the camel remains was subjected to residue analysis. This technique detects preserved proteins trapped in microscopic fissures on tool surfaces. Even after thousands of years, these residues can survive if they're protected from bacteria, moisture, and UV light inside the stone's microstructure. The scraper from Rimrock Draw tested positive for proteins consistent with bison blood. Not modern bison, but Bison antiquus, the larger Pleistocene ancestor of today's American bison. That's direct evidence linking the stone tool to butchery activities. And it shows people at the shelter were exploiting multiple large grazing species, camels and bison. Big game hunters with sophisticated tools and processing techniques. As excavation continued, archaeologists discovered another orange agate scraper buried even deeper inside the volcanic ash layer itself. That reinforces the conclusion that tool use at the shelter predated the Set S eruption and extended into older strata. The arrangement follows the law of superposition, a basic principle in geology. In an undisturbed sequence of layers, the oldest material lies at the bottom. Progressively younger deposits accumulate above it. At Rimrock Draw, the camel remains and tools lie below the ash. Additional tools sit even deeper. It's a stratified record where the earliest human activity predates both the eruption and the dated camel, which raises an important point. The radiocarbon date of 18,250 years is treated as a minimum age for human occupation at the site, not a maximum. Why? Because the dated sample is an associated animal remain found above the deepest artifacts. It's not a directly dated hearth or tool from the very bottom of the cultural sequence. It provides a no later than age. If people were butchering camels there 18,000 years ago, any artifacts or cultural materials lying deeper in the stratigraphy must be older. Some researchers involved in the project argue the site could ultimately prove to be older than the current benchmark suggests, potentially approaching or exceeding 20,000 years once deeper layers and additional residues are dated. That would push the timeline for human presence in North America even further back, deep into the last glacial maximum, at a time when the inland ice corridor definitely wasn't viable. Which brings us back to the question of roots. How did these people get to Oregon 18,000 years ago if the ice-free corridor wasn't open yet? The answer has to be coastal, moving south along the Kelp Highway, exploiting marine resources, adapting to coastal and nearshore environments, then spreading inland along river valleys and into the interior once they reached ice-free zones. Rimrock Draw sits inland, but not that far from what would have been the Pacific coast during low sea level stands. If groups were moving along the coast and then pushing into interior valleys, central Oregon would be accessible, especially if they were following game animals like camels and bison that ranged across the open grasslands and sagebrush steppe of the late Pleistocene. The evidence from the shelter shows that in this challenging environment, humans weren't just barely surviving, and beneath the deepest layers at Rimrock Draw, there may be even older stories waiting to be uncovered. Stories that will push the timeline back further still. Stories that will continue to reshape our understanding of who the first Americans were and when they first made this continent their own. On this channel, we combine archaeology, advanced dating methods, and cutting-edge residue analysis to rethink deep human history. Subscribe for more discoveries that rewrite what we thought we knew about the past.